Greetings, Tech Art Gang. Hey, this morning we were going over baby's first shader, and everything was working fine. Everything is cool. One of the things I thought we'd throw in here is just in case if I wanted to throw a slider in here to control my distance here, what I could do is just drop in a slider node here. If I go to types and I drop in a float slider, woohoo, I can put in a beginning and end. Let's just say 0 is at the origin, and I'll put, let's put maybe like 10 up on here. And we'll leave this at 3.5. And then I can hook this up to W, and I can slide this back and forth. And ooh, I can make things even go there. Or if I wanted to avoid having a slider, what I could do is actually drop in the mouse information where some stuff. Where's my mouse? Scene. Mouse. Okay, here we go. Mouse information. Okay, if I was to just drop in this, take the XY coordinates, drop this into Z, it's just going to take the X coordinates, drop this into here, and whoa. So I can control that. So shader tool is tons of fun to play with. There's lots to do with, lots of geeky fun to be had. But we're not here about talking about what kind of geeky goodness we can create with Shader Tool. We are here to create lots of goodness within our HLSL programming. And if you've noticed, some of our code is kind of awkward. It's not very easy to read, and it's kind of difficult to manage because we're just returning this type and returning that type, and it gets kind of hard to deal with. So let's go ahead and fix this. So what we're going to do in order to fix this, we are going to provide things called structures in our code base in order to kind of it's going to do the same thing, but it's going to kind of fix things up so that it makes things a little bit more streamlined, easier to work with. And we're going to add right to the existing shader. Remember, I told you that multiple techniques can exist within one shader. And so we can just pile high, kind of like on a submarine sandwich. We just keep on piling the meat on in here. And that's what we're going to do. We're going to pile on more meat. So I'm going to, where's my Sublime? Ah, here it is. All right. So what I'm going to do is first lay down some structures. And I'm going to lay down this structure. And see what I do? We're creating a structure. We're calling it VS input, and that stands for Vertex Shader input. Let me put that down here. Vertex Shader input structure. Basically, that just says, okay, the information going into a vertex shader is a float for, and it is looking for object position. That's all it is. It's just a structure, just this is a float for. And notice that it does have the whatchamacallit, the it does have the semantic in there in order to show you how it's going to be used. So we don't have to declare it in the future. The semantic is already covered here. Then so the next one is we have the vertex shader input, and so thus we need the vertex shader output. Vertex shader output. All right, and all we need here is a float for, and with the SV position as the semantic to go out. So that's the position going out. All right, now that we have that, how are we going to modify our vertex shader? All we have to do is I'm gonna create a copy of this and just pop it down here. And I'm gonna put a little there. I'm gonna call this struct driven vertex shader. And so for this, where it says float 4 vertex shader, we're not going to use that anymore. I'm going to put VS output because we want the output of our vertex shader to come here. VS output vertex shader. And so where it says object position and it's got the semantic for position, we're just going to change that with this whole end part here. We're just going to go VS input in. And okay, so there we go. There we go. So that means if we're going to have an input, that's not in out, that's input. All right, good. So we don't need this NOP variable anymore because we're there, but we're still going to need an output. So I'm going to replace this with a VS underscore output, and we're just going to call it out, and say equals, and we're going to cast it off. We're going to take a vertex VS output structure, and we're going to cast it to 0. And we do that by just by putting this in parentheses, saying VS output, and we're going to cast it to 0. So therefore, we're going to change a 0 into a VS output. And then we're going to reference, because, look at here, where it says VS output, where it has a float fork called position. So it's kind of like a little baby class in and itself. That's what a structure is. It's kind of like a little baby class. So we're going to change this. So we're going to say out dot position equals, and we're going to leave it all the same, but we're going to take the input dot, and it's called object position. So it's input, or we're pulling the input as the variable in. So in dot object position world view projection. Okay, and then instead of new point, we're just going to return out. Okay, piece of cake, right? Let's see. Okay, ambiguous function call. Oh, it's ambiguous function call vertex shader output. Okay. Vertex ambiguous function call 54. Oh, I get it. Yeah. In 54, yeah, vertex shader. I forgot to call this. Let's call this vertex struct shader. Because we're going to have two functions here. This was all called, this is the old vertex shader, and I'm going to call this one vertex struct shader. All right, now we have that one working. And so now let's do the conversion for the pixel shader as well. I'm going to copy this. And let's get this into perspective a little bit. Okay, we're going to call this pixel struct shader, and we're going to call that pixel struct shader. So struct pixel struct shader, and so the output, and it's still going to be a float 4 because we're still going to be outputting a float 4, which is 4 outputs for the red, green, and blue. But for the input, we're just going to put in. Now we're still going to need the SV target, but we're going to take the input as vertex shader output as in, and then we're just going to leave this as is. That's all. That's all the changes that we're going to do. So what we're going to do is we're going to copy this whole dealio, and oops, that's not what I wanted to do. Arg. All right, there we go. And I'm going to call this baby struct shader. Okay, and then I'm going to call this Vertex Struct Shader. And I'm going to call this Pixel Struct Shader. All right, I'm going to save it. All right, everything seems to be working. Everything compiles. We are ready to rock and roll. Okay, notice here that when we go over to technique, we have Baby's First Shader and Baby's Struct Shader. I'm going to choose Baby's Struct Shader. And everything stays exactly the same, and everything behaves totally as expected. So we didn't actually change any of the structure by going over into using, we didn't change any of the behavior of our shader by adding in the structure. We just kind of reorganized the data to be a little bit more logical sense. And because we can have multiple techniques within the same shader, we can kind of like pile load and create two different flavors of the same thing. Well, that's all I really wanted to talk about today in this little supplemental lecture. Sorry we ran out of time earlier today, but hopefully you'll be in real good shape to jump into Wednesday's lecture when we start diving into textures. See you then.